to confirm your programming before you transfer to the board. Right, this is the first interface for EasyCityAK. What you can see here, this is the file. This is the actually they call it, this is dot what else? Sorry, dot. Because of the EasyCityAK, the file will be .x68easy if I'm not mistaken. This is actually like the extension, like .docs, .txt, something. This is an assembly programming. Okay, this is the organization of the program like this normally. But we don't really want to know this one first. You can delete the whole thing. Delete the whole thing first here. Delete the whole thing. Just delete. Just delete here. Okay, welcome to first like hello world here. Now you write this code first. This one tab. The empty space when you start is a tab. Tab first and then you write. Tab, right. You have to make sure the color is the same. When you do programming, most of the software or the IDE will have the color-coded version for you to make sure that there will be no syntax around, syntax error. So write down that one first. Very simple. ORG means origin. DC is defined constant dot byte. That one, and then the program's end. Write down that one. Make sure the color is the same. So semua orang buat sekarang. Make sure you are on the same page. Do not waste time for other things. The empty space is not stack. This is defined constant. Constant is a number. Alright, so everything done? Byte. This is defined constant of byte. B means byte. Okay, that is the first program. This program means that you are going to save a number, but not a number, 4 numbers, 1, 2, 3, 4, to the memory location at 2000. 2000 is this one. This one means in your memory. Okay, let's go back to your memory bank. $0.000000, $0.000001, $00, F, another F, 1, 2, 3, 4, 5. This one is $F, E. Alright. That is that's my memory. Okay, agree? Now this program is the function of the program is to save save data to the memory location at 2000. 2000 is around here. Zero, zero, zero. Around here. And the size of this memory is what? 8-bit only. Okay, now you look at this memory first. Now you hit this button. This button. If you have error, this is a syntax problem. I do not have error here. I have 0 errors. But I have warnings one. Warnings okay. Just warnings only. Error means you can wrong mistake. Alright. So now you just execute. It will go to 2 different windows. One is this one. Another one is this black color one, right? So go to this view. Go to the memory. So far, okay semua? Belakang at the back, okay? At the same page. How to the memory? Go to this one. View memory. Okay? All that page with me? Okay, now go to this page first. The default value, the contents of your memory is default is all F. F means all high state. 1, 1, 1, 1, 1, 1. All of them. That's why you see all this information FF. And you see that the location, each location only consists of 2 digits of hexa, which is FF. Means that your location is only 8-bit size. Okay, here is the memory. From this one to this one, you see only 6 numbers is not gray. 6 number is not gray, correct? Because of your your address pins is only 24. So the maximum will be only 6 digits only. Now, you type this one, you type this address to 002,000. You type this one. You go to that particular location, go here, 002. That command will direct to you the page where the location start at 2000. You just imagine that 16 million, I cannot put in the same page, right? So that one is jumping to where is the location. So just now, the command, the program is to save data to the memory location at 2000. Do you see data over there or not? So the data now is already inserted at memory location origin started at 2000 here. This is a memory location for 2000. One memory is only 8-bit, but I send out a lot of data. I send AA, BB, CC, DD. So this memory location is 2000. The next one is 2001. Look at these references. This is 2000. This is 2000. 2001, 2002, 2003, and so forth until 2000F. The next address will be 2010 over here. This is the data, this is the address. Okay? So this is your reference. Where is the location? If I say, where is 2008? Mana? Sini kan? Agree? Where is 2008? This one, right? Where is 211F? Where is it? Look here. Right? This is the location, correct? So that is the locations and the memory. So look at the code again. This code means that I start my program at the memory location 2000. And the next command is to define constant. Define constant means you are going to put the data to the memory. For this case, I'm going to put AA, BB, CC and DD to the memory starting from 2000 because my program starts at 2000. When I hit this button, then it will save the information to the memory. The process will have to find out where's your location. That's all data bus, everything done. You can see the results only. At the background, you will know that where's the address register, address bus, all the information there. Then you will send over there. Okay, this one, okay? Alright, how to run this one? Okay, now look at the next window. This is one of the most important windows also. This window is telling you the components inside the CPU, which are the registers. So you have data registers D0 to D7, 8 total of them is this one. Okay, address register is this one. Status register 16-bit is this one. Program counter is this one. So the one that we learned just now from the slides is actually, this is the one by simulator. Okay, now let's try something first. We want to save the data. We want to save, not save, we are going to send data to the registers D0. Okay, let's try something. Okay, open up your Microprocessor that one. This is the one again. So instead of dc.byte, you can try move.byte. Move.byte. Is it correct? Move.byte. Okay, command, try to do that one. Move function is to store data in the data register. It's the command that will push the data to the data register. Hash, hash. Hash. Sometimes the software got bugs. I don't know why. It should have no errors. If you have problems, restart the game and try download it. No errors. There's a kind of errors. You try again. Look at the no, left down is data, the registers inside the CPU. This command say move. Move the data to the location. Here is move.long. Long is how many bits now? 16 is word. Long is 32. Alright. Now the command say, okay, my origin is starting at 1000. This is my memory location. This is my memory location. So move.long is the command to store data. You cannot literally. Move.long is sending the data to the data registers which belongs to D1. Hash means is a fixed value. It's an absolute value. If I remove this one is there. If I remove the hash, the command will know that I'm not putting a value, but I'm getting the information from this address location. That's very confusing. Now, if I put hash, you have to understand that is a number, that's all. If I put a hash, that is absolute number. It's a number. Without hash, it's referring to the address. Do not know, don't care what that one is. So hash a number. a long word number 11225544. You are going to store these informations to D1, and then the next one moved along. You are going to send the whole information to D2. This one you are going to add. Add.b means add.byte. Byte is how many? 8 bit. You are going to add 8 bit from these two locations, which is D1 and D2, and finally you are going to save the result in these two, and then the information is sent. Let's look at how it works. Now execute. Alright, we will show you these components. You can trace. If you want to troubleshoot, normally programmer will shoot one by one the lines. Okay, you can go to this button to do the one by one programming. Okay, let's look here. Now, my code waiting at this one. I hit this button. I hit that button, this one is moving to the next one. You see what happened just now? This D1 now contains this number. D2 still nothing. This is a register inside the CPU. Now this command is going to put these informations to D2. I'm going to click again this one. Look at D2. Look at D2. Long informations to D2. D1 and D2 already have the informations. This is the data register. The last command is to add those information byte. Byte means only 8 bit. Use your calculator, you can add this 2-bit number. You can add 44 and 77 by using calculator. 44 plus 77 in hex, what is the answer? 44 plus 77 is what the answer? The answer in hex is BB. Alright? Now look, where is the BB going to be allocated? Okay, this is my last command. Now look at these two components. I'm going to hit this button. Look at the data register, which is D2. Now your data register is already added and updated. Right? Again, this command says you're moving this number to this one. You're moving to this one to D2, and finally you are going to add the byte. Byte means two numbers from the back here, 44 plus 77, and finally going to be saved at D2, which is this number. Because of dot byte. Let's try dot W. There is a command. This is only D2. The command. I'm going to send it. This is a teaser. Okay. Now let's try. Let's try. And now let's try to move byte. Move byte. Move byte. Okay. Let's change to move byte. Move dot byte. Change this one to move dot byte. Look at the changes in your data register. What happens? Okay, change to multiply and then run by one. Look at the data register that's on D1 and D2. What is the difference? You run this one, no error, right? No error. Sorry. This is still moved along. This is Try W that one. Hey, who's pen is this? How many bits? W is 16. How many digits for hex? 4. So you add up 4. 5544 plus 6677 in your calculator, how much? The answer is? F.W will add 4 digits and updated in D2. You can test long after this before we go back to the previous one. Change this one add.w to add.long. Change again and confirm back with your calculator, correct or not? So that command is going to add those two registers because long is 32, correct? So it will add both numbers and update it in D2 register. So do you have the result correct? Your calculator say what? And then the register say what? Same. So your calculator also have a CPU there. This one also have a CPU. It's the same function. Long is what? L is what? Long. Long is how many bit? 32. Word is 16. Okay, go back to the last one. Okay, go back to this again. Okay, go back to this command again. We are going to play around words and long word again. Just now is the add function, add information, odd operation. Now you want to see more about the changes. This command is going to save the data to the memory, correct? Now you change the define constant dot word, define constant dot w, change it to dot w, check the differences between dot byte at the memory location.